For the last video in this section, we want to talk about some additional identities that we're going to be using so much this semester. Starting with these guys. The Pythagorean Identities. Okay, so we use these so much, but I want to show you how these are derived. So this is not magic. So one of the things that we had before, we had this connection. We said that x squared plus y squared is equal to r squared. Right? We had that, no big deal. What I'm going to do is I'm going to take this relationship, basically the Pythagorean theorem, and I'm going to manipulate this and bring in trigonometric functions. So I want you to see where this comes from. So if you happen to forget, you can build it. So the first one that we have is if we were to take everything here and divide by r squared. So if we do that, we have x squared over r squared plus y squared over r squared is equal to 1. Now, remember that sine is y over r, and cosine is x over r. So what we can do is that we can make these substitutions here, and this becomes cosine of theta squared plus sine of theta squared is equal to 1. But we tend to write this in a slightly different way. I don't even know that I can tell you why it is, but they typically have us write sine before cosine. It's whatever. But here's what we do. So we can write this as sine of theta in parentheses squared, but more commonly we're going to write it like this. So sine squared plus cosine squared is equal to 1. By putting that power on the sine and the cosine, this is that one place where that actually is a power. If you have the negative one, it's not a power. That means inverse. I know it's kind of weird and crazy, which is probably why I got confused back when I was young. But I'm telling you now, this is how we would do this. In much the same way, like if I wrote tangent of theta to the 5th power, I could write that. But more commonly, you'll see it like this. It's just a nicer way to write that. And the reason for that is that it's to avoid ambiguity. Because if somebody were to leave off parentheses, it might look like you're saying tangent of theta to the 5th, as opposed to tangent of theta, that whole expression to the 5th. So to avoid any kind of miscommunication, we're going to write the power here. And just like you see here for sine squared and cosine squared, that way it's never accidentally applied to the angle measure. So this guy is super big, super important. We're going to be seeing a lot of him. Okay, so that is what happens if we are to divide everything by r squared. Okay? If we take the same guy and instead we divide everything by x squared, then what we end up with is the Pythagorean the Pythagorean identity of tangent squared plus 1 is equal to secant squared. Now I know you might say, shouldn't this guy here be 1? It should be, but we're just kind of flipping it around. No big deal. And the way that you would get the other guy, so we divide it by r squared, we divide it by x squared. If we divide everything by y squared, what happens? Well, y squared over y squared is 1. X over y is cotangent, so this becomes cotangent squared. R over y is cosecant, so that becomes cosecant squared. So these three guys form our Pythagorean identities. So you've got to know these. So sine squared plus cosine squared is 1. You see that guy a lot. Tangent squared plus 1 is secant squared, and 1 plus cotangent squared is cosecant squared. But also know that we can rewrite these guys if we need to. For example, this guy could be rewritten as 1 equals cosecant squared minus cotangent squared. So just be ready to rewrite these guys or to be able to recognize them when they're in different forms. Because you do have an equation, there's definitely room for manipulating. All right, the other ones that we have here to learn are our quotient identities. And these are exactly what you would think they are. They are quotients. They are fractions, right? And here is the like super big one we see all the time. And this is sine over cosine is equal to tangent. And if you think about what each of these guys means, so sine is y over r, cosine is x over r. Remember that to divide a fraction by a fraction, you multiply times the reciprocal. When we simplify, we would have y over x, which is how we are defining tangent. Okay, so we can write it like this. You also could write this as secant over cosecant. That would also give you tangent. That's a little less common to see, but this one for sure, we see him a lot. Sine over cosine is tangent. So if we're doing this, we'd also talk about kind of like the flip of this through the reciprocal. If I do, instead of sine over cosine, I do cosine over sine, that's going to give me cotangent. Or if you're wanting to be super crazy, we can do cosecant over secant. But anyway, so you've got the quotient identities, you've got the Pythagorean identities, we did the reciprocal identities before, and so we're going to be putting all these guys together so that we can answer all kinds of fun questions and to do proofs. It's going to be a blast. But you got to memorize these, especially sine squared plus cosine squared is 1, sine over cosine equals tangent. You've got to know those guys and know the reciprocals. With those, you'll be able to get through the vast majority of this content. But you got to practice with this. You got to practice and you got to memorize it. You can do it.